What you should recognize is that this is already written as one fraction over another fraction. So this is kind of the end result of step one on the combining fractions method. Okay, so if you choose on this one to just factor the fractions, invert and multiply, you should be able to get the answer pretty quickly. Okay, if you factor first, our first fraction has a numerator with a difference of 2 squares, so it factors into the sum and difference of the terms being squared, which are p and 10. So here's our first fraction written as factors. We can then invert and multiply because our second fraction is already written as factors as well. The p moves up to the numerator. The p minus 10 squared are just 2 individual factors of that now get moved to the denominator. When you cancel any common factors, the p's cancel. P minus 10 cancels with one of these, and you're left with your solution here of simplified form of p plus 10 in the numerator, p minus 10 in the denominator. There's nothing else that simplifies or cancels here. And when you look at your domain restrictions, you look for any canceled factors in the denominator plus any uncanceled factors in the inverted fractions numerator. P got canceled here, so p can't equal 0. That's not apparent in the simplified form. Even though we've canceled a factor here, there's still a p minus 10, so you know that p can't equal 10. You don't need to include it as an additional restriction, and so that would be your simplified form. Now, if you did use LCD method, you can multiply top and bottom by p over itself. If you did that, you would get p plus 10 over p minus 10. If you thought of this in the LCD method, multiply by p over itself in the numerator. When you multiply here, the p's cancel, giving you p plus 10, p minus 10. And when you distribute the denominator, the p's cancel, giving you p minus 10 squared. And once again, you wind up with the same thing. Go back, check your original domain restrictions. P can't be 0, and that would be your restricted value.